So I wanted to talk about software and the Neoplatonic ethos. Now, I don't think there's any such thing as Neoplatonism. I keep asking people where it is, and they keep not being able to give me an answer. It's an easy enough question, so I'm suspicious. And yes, that's my heuristic for everything, and it's pretty freaking good. Works really well. Ask simple question, no answer, probably not a real thing. Can't do that with just one person, obviously. But you ask a few PhDs in history about where Neoplatonism is, they fail to identify it. Good bet that it's not there. So why do I want to link this Neoplatonism to software? Because James Lindsay did an excellent talk called WTF is SEL, and it is fantastic. It's long and rambling, actually, but he makes the case at one point in a very small part. But who knows how much of the scaffolding he's giving there is required to make the point that Neoplatonism is occultism. It just leads right there. So if you think of Neoplatonism as having two paths, one is towards, we'll say, Christianity, and the other is toward Gnosticism, then yeah, it seems right. And I think that's true. And there's good evidence for that. First problem, Neoplatonic thought is dualistic. It is two things. Two. Somebody says, I'm not a dualist, and lists two things, they're lying. When you list two things, you are a dualist. That's what you're doing. Right? It's definitional. It's not hard. It's confusing because allegedly smart people do this constantly, but they're just dualists. So what are the two things in Neoplatonism? The one and the many. It's not hard. The one and the many. And you may say, well, how does this relate to software? It's really easy. The problem with software is identifying the one and the many. That is the problem. That is the problem in software development. So what we've done is we went from a monolithic software model to microservices. Yay! We did this because people are following Netflix, which is a mistake, by the way, because A, they don't understand how Netflix works. B, Netflix largely lies about what they're doing and how it works. And C, Netflix admits this isn't for everyone. So why is everyone doing it? Good question. Now, the problem of building a piece of software, an application of any kind, okay, we'll set apps on your phone aside for reasons which I won't explain here, but may go into some other day. Apps and applications are actually different entities in terms of development process and what's actually going on. Roughly speaking, any retard can build an app because it doesn't take much. There's a lot of framework involved. But what people can't do, no matter how quick you are, is build an application, because an application requires a lot of grounding and groundwork. And that's the problem, is that it doesn't take long. It doesn't take a lot of speed. It doesn't take a lot of intelligence to build an app, because most of the framework is there. You know what you're running on. The screen sizes are fairly well set. All the libraries are done. All the input and output is taken care of for you. In an application, none of that is true. That's not to say that you can't make it true, and that's largely what the industry has done. But your boundaries are not the same. You're not bounded by a phone, for example, or an app store, for example. So you have to be pretty quick to run through this stuff. Like, you can't just whip it out in a few days. It takes time to build an application. When you're building an application, you are using parts. In a monolithic application design, those parts are usually functions, or in OO land, they'd be classes and methods. And so it used to be an 80-20 design rule in software, right? Where 80% design, 20% actual coding. So all your work was design. You'll notice the 80-20 rule, we're following the Pareto principle. This was way back, as near as I can tell, in the 70s. They had this model, so this isn't new or anything. And it was well in use into the 90s, from what my research shows. So, and there are obvious exceptions, but whatever, there's always exceptions. It's not useful. the majority was, coding along. Now, what we're doing now is microservices, right? Everything's service-based and APIs. Now, an API call is equivalent to a function call. They're absolutely the same thing. From a data perspective, from every possible computer perspective, they're the same thing. But an API runs as its own independent piece of code. And so what you're doing is, instead of linking everything at compile time, you're linking everything at runtime. And linking is just getting pieces of code to talk together at the end of the day. Can be a little more technical than that if you want to dig down on the differences between, say, C and something like Java or Python. Fair enough. But at the end of the day, getting the pieces of your program to talk together is linking them. And whether you do that at the compile side or at the runtime side actually makes a huge difference. How is this Neoplatonic? Where is the one and where are the many? In a monolithic software design, the creation of the application happens at compile time. That creates a package. You can distribute that package to your users. They can run it. It's one thing. In modern software development with agile technologies or approaches, I should say, it's really not a technology, it's just a bad idea. What basically happens is your one doesn't happen until all of your code is up and running in the various parts of your infrastructure. And oneness only happens as a result of interfacing the software. So you can't package it and hand it off. I mean, there are ways to force that operation. But even if you do, and you're making API calls, ultimately at the end of the day, there's no way to know if they work until you use them. And you could say, but you can use them in a development environment, and it doesn't work. It just doesn't work. It doesn't work for very well-known, easy to understand reasons, which nobody seems to understand. And there's math behind this. It's done in the 60s in software development. There's math behind why. First of all, whatever data set you have for almost every application, not every application, but almost every application, it's different in production. There's stuff in production that you don't have a representation of in non-production environments. It's almost inevitable that this is going to happen. There's lots of very good reasons for it. But we'll just set those aside. What that means is that there are bugs that are related to the data in production that you will never see until you go into production. Now, there are ways to fix this and avoid this, for sure, but they involve making sure your software is done in development and tested as an individual one app in development the way it would be used in production, and that the engineers working on the project actually understand how the software works so that they will check for all the data conditions and automatically fix them. I've seen this can work. It takes very bright engineers, and most software industry doesn't have very bright engineers anymore because we've just given people, coding boot camps and told them they can be software engineers, and that is not working. Some people can be software engineers without a boot camp, for sure. I did. It's not hard, not for me, but it might be impossible for most people. I have no idea. It doesn't really matter. What matters is we've told a bunch of people who clearly don't have the skill that they can do something they can't do. And now they're in the industry trying to do that thing, and it's not working. And the industry is suffering, and all the users are suffering. Still unstable. What was stable for like 2 months? 7 updates a day now. Don't know why. 100 apps, 110 apps maybe. That's it. Very minimalist phone. 7 updates a day. I don't know what they're changing. Nothing works. Like, everything's completely unstable, but whatever. That's the accelerating pace. This is what happens when the one is some abstract sort of running, always on, being piecemeal replaced, right? Inserting in the middle. Like in the old days, you'd have to fix a bug in a function, recompile your code, right? And then see if it worked. And now you just push that function, which is now a microservice, into the cloud. And the problem is you don't get good feedback from your users like you used to, because you don't even know who your users are, because they're all on the cloud. And if you have good error tracking, which I would argue would mean you almost certainly never actually hit the error, because if you knew about the error, you'd just kind of correct it. This isn't 100% true, but it's 99% true. And I've seen projects where they did it and it works fine. I actually worked at a company that had software that was so good the QA department was bored, and all they ever did was check for GUI errors because the software checked itself. Yeah, they wrote a piece of software and the tools around it. So they wrote a second piece of software to check the validity and the bugs in the first piece of software. And so by the time it made it to the QA process, it was pretty good. Not that they never found errors. They certainly did. It was just super rare. Like 1 a quarter at most. In fact, I think when I was there for the year that I worked there, I think they found 1 bug that wasn't a UI bug. All the other bugs that the QA department found were UI bugs. Every single one of them. So yeah, there's that. And I think that's part of the problem, is that the one and the many are confused. It's a dualistic world. And software isn't merely the sum of the functions you've written, which can be divided up, spread out across, and just put in place. And to be clear, this didn't just switch, right? It started out with the monolithic software design, the 80-20 rule, and then it moved to services, which is actually the best possible model, in my opinion, for almost every large piece of software is services based. But it never got to microservices, because if you design it correctly, your services actually make sense, and you can find bugs easier, and you can contain bugs easier, and it's way easier to manage, because not everything can call everything else. And if you need a custom function, you can just copy the code. In the old days, making copies of code was actually a big deal. Nowadays, it's actually not, especially not in version control. It makes no difference at all, functionally speaking. And we actually should copy and customize more code. Instead of trying to make it generic and then layering things on top of it. We should be copying the damn function and just having it named differently for different purposes. It's not expensive anymore. The reason why they didn't do it in the 70s is because it was expensive. It's not expensive anymore. Now it's super cheap. But what is expensive are the bugs created by trying to layer things on top of baseline functions, because it's the one and the many problem at a different scale, right? Do you want a large monolithic function, or do you want a bunch of small functions that lead up to a large monolithic function, but then you can have 2 or 3 of them? Well, that's fantastic. And that's what Neoplatonism leads to. It leads to this splitting up and layering. And then it's like, the one. Yeah, which the one? Who's deciding the one? See how it's Gnostic? Neoplatonism can't lead to a single anything. Neoplatonism has to lead to whatever single thing the person engaged in the Neoplatonism wants. There's no other option. It's not coming down from above. It's not coming from the outside. There is no outside goal or telos or ethos or aim. It's not there. It's all emergence. It's all coming from below. It's all how I'm arranging the parts. And you could say, oh, the Neoplatonists didn't think that. Well, the ancient Greeks didn't think that before Plato. After Plato, they certainly did think that. Every single one of them seems to have been a crazy polytheistic cult. As far as I can tell, none of the Neoplatonic groups were large by any standard. They didn't leave anything behind, so they didn't last. They got wiped out by Christianity, roughly speaking. So what's going on? Well, and I think we're in the middle of that in software, right? This crazy Neoplatonic approach to just splitting things up so that the one piece of software you're running, the Netflix, exists somewhere when you run it, is dangerous. Because now we have a bunch of pieces of software that are broken all the time. Netflix is not a stable piece of software at all. They tell you, if you watch their talks on DevOps, they'll tell you this. Their software engineers are constantly releasing new copies of functions into the software in different regions all the time. So just because Netflix works in your region of the country for your city doesn't mean it works one city over. How that division is made, I couldn't quite tell you. I have some idea. They're using head nodes, and so they're basically have a huge distributed cloud where they've given people super servers with petabytes of data in them. And then that region is handled by a set. So it's not one piece of software, actually. What they're actually doing is running many copies of their software, which is hysterically funny. So at no point is there a one Netflix. The software that's running in your region may actually not be the same as the software running in another region at all. It could have some fundamental difference. And this is cool because you can upgrade it region by region. This is a well-known strategy. It's been in software since the 90s. Used in different ways, obviously, because that was sort of pre-cloud. Used in clustering technologies, especially high-performance clustering technologies, and outside of that. So not just high-performance clusters or clustering. It was also used outside of that. This idea of rolling upgrades and stuff is very, very old stuff. It's known from manufacturing, materials manufacturing even. So it's not something software thing. So it's cool that they can do that, and that's kind of neat. But now there's no one anymore. Technically, there is no Netflix because it's not one thing. And at any given time, the developers are pushing changes into regions. And there's no reason why the regions have to run the same software. So, and I don't know how Netflix does business in China, but technically, they could have totally different ways of relating in China with totally different pieces of software. And you would not know it from the front end. There's no way to know. And the development cost for doing that is very, very cheap in a microservices environment relative to the development costs of doing it some other way on the surface. In reality, no, it's not. I can make a monolithic app just as cheap doing the same thing. I've seen it done. I've worked with many companies that have done it. It's not a big deal. You have to design it correctly, and design is hard. But once it's done, it's way more stable. And that's the problem. So you can see the Neoplatonism is everywhere, but ultimately it just shatters into 1,000 ones. It can't hold itself because you say the one, but you're a dualist and you're a relativist because you can say the one and I can say the one and we can all just say the one and we can be talking about different ones. That's not hard. That's what happens. That's why it's Gnostic by design. It can't not lead to Gnosticism. It needs to be contained within a larger story, right? If you want to cast that as a narrative, that's fine. And then once it's contained within that narrative, those ideas become useful. They're not useful on their own. They're not useful as a stopping point because it's dualistic and doesn't work. It doesn't work in software. It doesn't work in materialism at all, right? And I just find this fascinating. So hopefully, no idea how clear this is. Hopefully, I've demonstrated this is happening in software. It's already happened. It's been happening for like 10 years in software with people following the Netflix model. It didn't work. We've broken everything. Like 80% of the websites I use are broken. I was on a website the other day. I couldn't give them the information they were asking for, so I couldn't hit the next button because their drop-down was broken. I was like, your drop-down's broken, dude. How did you break a drop-down on a website? That's remarkable. It must have taken a lot of effort. No, it doesn't take a lot of effort. Things are just broken all the time now. And no one's writing their own software. It's parasitic. Everyone's using libraries from Java and libraries from Python and libraries from wherever. And they're using frameworks that they didn't write. It's all parasitic, right? Amazon Web Services, 0% new software engineering. It's all open source. Like almost all of it is actually open source. Sure, they've modified pieces of it, but modifying software is way easier than developing it from scratch. The two aren't even comparable. It's a crazy world. It's a crazy Neoplatonic, fractionated, polytheistic, occultist software world. Stay safe.